All right, so this is how it ended up laying out inside of there. I've got the two 100 amp hour batteries connected with a little hook and loop and tilted on their side, wired in parallel. As you can see, the inverter is positioned vertically, immediately adjacent to that, and solar charge controller. Back here we have the two bus bars, and the negative from the battery wires directly to the negative bus bar, and the positive goes through this breaker for both circuit protection, and it also allows me to essentially be able to shut down the system. I was amazed at just how perfectly sized this toolbox turned out to be. It took a lot of figuring and thinking about how to position it, but I'm pretty happy with it. As you'll see, this pink stuff here is just insulation. This battery, other than them being connected to themselves, it's essentially just wedged in here. So this down here is the solar charge controller. And this just talks about how fantastic this toolbox just turned out to be. The cooling fins actually fit in between there. So what that allowed me to do, it just so happened to be just the right size of this solar charge controller. If you guys can see right there, these little fins that were part of the toolbox slid right into that heat sink, and this is just sits down there and is held in with friction. So what that means is it's very easy for me to pull components out of this. As you guys can see, what we have up here is a circuit protection, but it also kind of functions like a switch. So if I want to shut off the solar, I can. And the two solar inputs are right here, sticking out of this. Let me go into standard mode here. You guys can see those two right here. Right here is the DC output, just via a cigarette lighter socket. And all of that is wired down below this piece of wood that fits in there, and I'm going to explain why I have that wood in there. We'll get a little flashlight down in there. So you can see the two solar, you can see the cigarette lighter plug in there, and all of the wires for the solar charge controller and all those devices run underneath the solar charge controller. So if I needed to access them, I just pull that out, and then they come up into here and come into the bus bars. Right here where my light's shining to the right there, that is the shunt for the monitor, which sits right here. Tells us our voltage and solar input, etc. This right here is the remote on for the Bouge RV inverter. So what that does is you can remotely shut it off, or you can turn it on. In this case, if you had it inside the box here. So right here is a fan, and then right here is a power strip that includes some USB plugs. So these wires for the two monitors and for that power strip, and I relieve the plastic right there, come up over the top. And then right here, and this is where I'm going to get into the fan and this piece of wood that I pulled out right here. So this right here is, I believe it'd be called a thermo switch. It has a little heat sensor, which I put against the inverter here. And then this is wired into this fan down here, essentially via a switch. And then this has power. And what that does, and this is in Celsius, is you can adjust this so the fan will kick on. So let's go ahead and lower this real quick here. See if we can get the fan to kick on. There we go. Right here. And then now this fan right here is running. Now, here's my thought. One of my biggest concerns about this setup was heat dissipation. Usually, obviously, you want these inverters to have as much airspace around them. But the flip side, and one argument I would make, is that in a purchased solar power bank, obviously they're going to have to confine this stuff. So this particular inverter has two fans, and they're pretty strong, and there's an internal system that kicks them on when it reaches a certain temperature. So what you see up here is the intakes for that. And then those fans are pointed down toward the bottom. So when they're intaking air on the top, they're pushing that hot air down the bottom. So what this fan does is this fan is pulling from down there. So down in that little crevice, sorry, I know it's not focusing down there. There we go. That would be where the hot air is blowing out. So therefore, if I put this piece of wood over the top of the fan, it's not perfectly airtight, But what that's going to do is it's going to force this air, or this fan right here, to pull more of the air from the output of the inverter. And then on top here, what I did is I put this vent. As a cool little side note, I put the thermo switch to where I can actually look at it through the vent. I just did that for fun. I thought it kind of looked cool. Now you'll notice one thing right here is this vent is to the right of the top of the inverter, or where the intake is. You see that? See this vent right here is to the right, and that is purposeful. The reasoning is this. It is sometimes said that you shouldn't mount the inverters like this. And I want to make one thing clear. You guys don't rely upon me on this. Do what you feel comfortable with. However, I'll say for myself, I began to research and say, well, what is the rationale? And the rationale was for not putting it like here was debris, at least from what my research showed, the fear that debris could get in here, maybe short something out or cause damage to the fan. So my thought process is, and one of the genesis of building this in the first place, was in normal use, this top will be shut. So those vents are going to, because this is offset, debris and stuff is not going to be easily able to get in there. However, from the inside portion, as you guys can see, that I had to relieve this right here, so that way when it sits over the inverter, it holds it in place. But you can see right here, there's free access to get the air. So the theory is this: inverter internal fan comes on, intakes air through this, which comes through this vent. It blows out the bottom, and then if it reaches a certain predetermined temperature, this fan right here will kick on and pull the air out. So it's kind of this rotating cycle. And then the air for this, or the air pressure for this, would come both from the air coming out of this, but there is also still a cavity down here that air can be sucked from if need be. One thing I wanted to mention was that both the solar charge controller and the inverter from Bouge RV have Bluetooth capability with app monitoring. That also includes built-in Bluetooth in these Vatrer batteries. So though I have an external monitor to watch various parameters, the real nice thing is, you can, once, when you have these powered up, you can open up the app and you can monitor all kinds of components, change all kinds of settings. Because I know one of the things someone might be looking at is this solar charge controller is buried in there. How would you change settings? Well, I mean, frankly, it's far easier to change the settings on the app. So there's really no need to actually have to constantly monitor the solar charge controller unit. I'm going to be honest with you, maybe I'm a bit of a Luddite, but I typically don't like downloading a bunch of apps on my phone, and I try to avoid it. But the app functionality of, batteries, inverters, and all kinds of devices in the camper RV world is becoming so ubiquitous that, and I have to admit, it is really nice to just, plug in the app and know exactly what's going on. So, but some of you guys were wondering how I would do that. But I also have a backup. I have a good old traditional monitor, traditional remote turn on here, because you could actually turn this inverter here on and off just via the app if you wanted to, which I thought was kind of